Hello, in this video we will solve Natas 17. So when you open the web page, you will see that the web page resembles level 15 of the Natas with the same username input field and the same check existence button. Let's open the source code and find out what's different. The source code too is practically identical to level 15, except now the echo statements have been commented out, as we can see. This means we'll not be getting any text feedback from the web page at all, no matter what query we provide to the database, which means that the simple blind SQL injection will not work here. Still, the web page is vulnerable to SQL queries and their injection. So what we will be using here is called blind time-based SQL injection. This type of blind SQL injection relies on the database pausing for a specific amount of time and then returning the result, indicating successful SQL query execution. Using this method, an attacker enumerates each letter of the desired piece of data. Using the logic, if the letter is present, the database will pause for a specific amount of time. We'll follow a logic similar to the one we did in level 15. We'll create a Python script, but we'll change up the Python script for level 15 a little. The new Python script will look like this. We'll add, this was our old command that we used. To this command, we'll add and sleep too, because we need to find a way to pause the database for a fixed amount of time. If the database does pause, we'll find out the character actually belongs in the position in the actual password string. Hence, we'll update the current password. Now, we'll be using the time module to find the number of seconds since an epoch before the post request is made. The difference between the two variables must be equal to the time response time. We'll be using the sleep command in SQL to delay the database as shown. Although the response time without the sleep statement depends on your internet connection, normally it should take around 0.2 to 0.05 seconds to receive a response with any explicitly induced delay. Here we are using a time delay of 2 seconds. So if the condition matches, the database will wait. We have added and sleep to the last part, while normally and where you add and does not matter. In this command it does matter, because if the first part of the query is not followed, it will not reach sleep to and the database will not pause. This is usually called short circuiting of the AND operator. You can find more about it in the internet or in our documentation. So we'll execute the Python script similarly. The script starts trying for the brute force password. It should take a few minutes for our password to be built since we are using the brute force approach. But similar to level 15, at one point the current password should stop growing in size and will find the password. We know that the Natas password are usually 32 characters in length, so we have added a break operation at that point. I executed this command before to show you the final results. This is how the final results would look like.